Right, I got so busy slagging off the first part of question 9, I forgot it went over the page for the next two pages, excuse me. So this is question 9.2 of the year 13 2018 mock. And here we get into some specifics about the production of methanol. Calculate the amount in moles of carbon monoxide and of hydrogen in the equilibrium mixture. So we're starting, let's put the equation so we know where we are. Okay, and here, so we put 20.1 of carbon monoxide in and 24.2 of hydrogen in. It established an equilibrium, and at the equilibrium, naught to start with, and at the equilibrium we had 2.16. So calculate the amount in moles of carbon monoxide and of hydrogen at the equilibrium mixture. Right, so it's 1 to 2 to 1. So for every 1 mole of that, okay, so it's 20.1 minus 2.16, and it's going to be 24.2 minus 2 times 2.16. Is that right? Yes, that's right. Okay. So that's going to be there, and that is going to be there. Where's the trick in this? Well, the trick in this, look, they've given you 3 significant figures there, and 3 significant figures and 3 significant figures, and so you should give your answer in 3 significant figures, even though you're itching to give it in 4, which is what your calculator will give you when you do that sum. Yes, don't. 3 significant figures it is. A different mixture of carbon monoxide and hydrogen was allowed to reach equilibrium at 600 K. At equilibrium, the mixture contained 2.76 moles of carbon monoxide, 4.51 moles of hydrogen, and 0.36 moles of methanol. The total pressure was 630 kPa. Calculate a value for the equilibrium constant Kp for this reaction at 600 and state its unit. So the clues here, well, first of all, that's a clue, Kp, and we're given a pressure. Okay, so we're going to need to work in partial pressures. So to work to partial pressures, we need to work out the total number of moles. So the first thing we're going to do is work out the total number of moles. 0.360, and we're going to find that makes 7.63 moles in total. So the mole fraction for each of them will be 2.76 over 7.63 and 4.51 over 7.63 and 0.360 over 7.63. Those are the mole fractions, but I want partial pressures. Well, if I know the total pressure is 630, the partial pressure exerted here will be 2.76 times 630 times 630 times 630. Right, good. So now I've got my partial pressures, I can go to the equilibrium constant. I'm going to say lab rat, aren't I? I'm going to say left at the bottom, right at the top. So at the top I've got carbon monoxide, so that's 0.360 over 7.63 times 630 at the top, and at the bottom I've got carbon monoxide, 2.76 over 7.63 times 630 times the hydrogen, which is 4.51 over 7.63 times 630. Okay, but if I look at the reacting equation on the previous page, look, it's 2 there, 1, 2, 1, right? So these guys are to the power 1, these guys are to the power 1, this guy's to the power 2. And then with deft and non-monkey fingers using of the calculator, I'm going to be able to work out the answer. I am indeed, yes. So that will be an answer, definitely. I'm not giving it to you because I'm mean. But I'm asking also to work out the units. Well, the units are going to be kPa over kPa times kPa squared. So that equals kPa over kPa cubed. So cancelling out, that's kPa to the minus 2, isn't it? Yes, it is.